do. How do I see what it looks like? Hey, how's it going? I am up and Adam kind of late today. I've been sleeping in. It's nice. Anyway, here to do the 9th challenge in the 30-day LeetCoding challenge. And we scroll down here, we can see it's called min stack. Again, I don't know if it's easy or medium or hard, but so far they've all been easy, so maybe that's what we got today. Oh, here we go. We got to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Okay. Interesting. So constant time means, basically O of 1. So I'm trying to think what that means for like the kind of array type in JavaScript. I've never done a challenge like this on LeetCode, so this is my first time seeing multiple functions. I didn't even know it could do that. So that's interesting. So in a normal kind of JavaScript array kind of, using their built-in object type, a push would normally be constant. A pop would be constant. Top as well. Get min is not. All right. So I think that's okay. I'm just kind of wondering, I'm just trying to make sure like there's no linear stuff going on. So if I do a push or pop, is that truly constant? Thinking, so basically we've got a vector. If we push to it, we add an item on. Push, 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 push. We pop. Take it off. I'm wondering if a linked list might not just be the better way to do this. We could do it in reverse. So if we did a linked list, it would definitely be constant to add an item. And we would do it in reverse. So basically, we'll have our head and we'll point to you push a 1. There you go. Now when you push a 2, push a 3, you look at the top, there it is. When you pop it off, we just say the head.next equals head.next.next. So that's good, that's definitely constant. And then I'm not relying. What's up, Kay? What you got for me today? Thinking about doing this problem as a linked list. So I kind of feel a little queasy, not sure really what the JavaScript underlying implementation of the array is going to look like for pushing. And I want to make sure that I do this problem in constant time because it asked me to. So I think a reverse linked list is basically the way to go. Get min is another thing. So I think that the trick to min is basically we'll just keep track of the min as we go along. But that's kind of gross too. Yeah, so I think that's probably the trick here. Because I always need to get the min and I need to get it in constant time, which makes me think of a heap. A heap will definitely let us get the item out in constant time, but I'm not sure that the heap will insert in constant time. So the deal is if I kept a separate heap and then I pushed the element onto the stack, then my runtime is going to be related to the heap size. And at first I thought I would just keep a variable of the min. But the problem with that is that if I pop the min off, then I have to know what the next min is. And I can't scan the whole linked list because then I'd lose my constant time. So I'm just going to Google the min heap insert time complexity. Insert is constant. There we go. And I know that finding the min item there is also constant. The thing is, I don't know if I remember how to do a heap without looking up the algorithm. I remember it being really cool. It's always kind of happens balanced, so I remember that. So, what do you think? Is it cheating for me to look up the algorithm for a min heap? I don't know. If I was an interview, I would definitely just say, oh, I'd use the min heap. Of course, I would have struggled with the insert time there. So I guess I need to get some flashcards together or something. If I was interviewing, I'm not. Oh, actually, it does say the insertion has a worst time of O log n. So that would not be constant big O. Is there another way that we could keep track of the minimums? What's up, Abdu? Insert the same min to array. Okay, so basically I'd yeah, keep track of the minimums as I go along. Okay, yeah, that makes sense to me. And then whenever I see a new min, then I put it on there. I mean, every time anyone's ever talked about min and max, I've heard heaps come up. So I kind of feel like that's like the secret area. I think if I always put the new minimum on top, that I also have to worry about not just putting the minimum on there, but also ones that aren't the minimum, which means inserting that thing in as we go along, which is constant time. Or sorry, not constant. It's linear time. So I think if I were to, if I had a list that was like, say, a list of mins, so it's basically a sorted list, and I have to insert a 3 into this, then I have to iterate this array in order to say, okay, it goes here, which is going to be linear time, which kind of breaks the rule here. Geez, I don't know. I think I'm going to go ahead and start coding here. That's a great idea. And then maybe we'll get some sort of hint or clue or something will become clear. So, equals next null. All right, when we push, we will say, actually I want to do this dot head. All right, then we say this dot head dot next equals, we need a new node, which means this also needs to have a value of null. So we'll say the value is now x, and the next is going to be this dot head dot next. So whatever's currently in there will become our next, and then we'll push it. So that looks a little weird, so I'm just going to do this. Say new node equals that, and then we'll set that there. So that's our linked list. That's it. To pop, all we do is we say this dot head dot next is going to be the value. So So tell you what, let's do top first. Which returns the topmost element. So we'll return this dot head dot next. And so here for pop, what we'll do is we'll say popped value. Oh, but we need to actually return the value. Okay. Because they don't care about our data structure. So result equals, and I can just say this dot top, and then I actually have to get rid of that item, so it's basically just this dot head dot next equals this dot head dot next dot next. So a little problem there if we try to pop an empty list. Coding challenges like this usually don't give you stuff like that, give you problems like that edge cases, so not going to worry too much. Now here's the problem child. For now, I think I might just return this dot head dot next dot value just to kind of see how that looks. See if anything passes. Val result. Val. Oh man, I work in too many languages. So that's a Kotlin thing. I also didn't return the value. All right, try this again. Happy Friday, by the way. I'm off from work again. Hey, did I get it right? Null, 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 null. Null, 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 null. -3, null, 0, and then -2. Okay, so push work, push work, push, get min happened to work. Pop, top, and then get min. So I'm not surprised to see that we return 0 here because we just returned the first element and not the actual min. So, geez. I definitely think that the secret to keeping the min is, or knowing what the next min is adjusting some sort of data structure on the push and the pop. So we can't search for the min, so that would always be constant time. Or, geez, I keep saying that, I'm so sorry. That would always be linear time. Jeez, this is messing me up. Is it even possible to keep a min, to maintain a list of minimums in constant time? Design a stack. Okay, here we go. We good. If we read the problem carefully, it says design the stack that supports push, pop, top, and retrieving the minimum element in constant time. So if we parse this sentence, then here's the way I read it. Design a stack that supports this in constant time. But if we choose to read the sentence instead as like this, then maybe what they're saying is push, pop, and top can be whatever, but retrieving the minimum element in constant time needs to be constant. Yeah. So so in that case, Abdu, reading the problem like that, I'm gonna go with your solution, which means I don't have to cheat and look up the algorithm for what you call it, min heap. So what we're gonna do is change our push and pop to insert this thing and just maintain the order. So I'll keep another one called mins, and do we want to do an array? I'm going to do another linked list here. Keep the same format. All right. So I'm going to make a little helper function. No, I'm not. I'm just going to do it in line. I'm going to be lazy. It's Friday. Take some shortcuts. All right. So whenever we get a new value, then I need to make sure to insert I need to maintain the min list. All right, so what we'll do is basically loop through our min list and figure out if we need to insert another one. Okay. So basically, while this dot mins dot next is not equal to null, actually, I'll do let current equal this dot mins, and we'll say while current dot next is not equal to null, and this will traverse it. So just in here we have to say if x is less than our current dot value, if it's less than, ugh, this is making me wish I had a doubly linked list. But do we want to do that? I don't think so. So we'll just tweak this a little bit. We start at the head, which the value is always null. So we'll say if x is less than, and we know current.next is not equal to null, so we'll say current.next.value. Then we'll say current.next equals a new node with value equal to x, and next equals current.next.value. No, sorry, just current.next. And at that point we can break out of the loop. Now we do have to worry about inserting at the end of the list. So we could say basically if current, oh, well, it'll break out either way. So I could just do this. So if it's less than the next value, then that will mean we found our current place in line, so we'll just break. Otherwise, we keep moving on and iterating through our linked list. Is this making sense? And then at the end of that, we'll know that we found the appropriate spot, so we know that current.next equals to us. And I'm in the same kind of case above where I've got kind of a weird situation. So we'll say, we'll call this new min equals that. And there we go. This makes me kind of uncomfortable to have setting something that's setting this equal to that. Just awkward. All right. So I think that did it. Now, when we pop, we have to do something similar. We have to maintain the mins, which basically means we have to go and we have to pull out our value from the mins. So this is, we can have duplicates in the list, but I don't think it matters. Yeah, it doesn't matter which one we remove as long as we remove one of that element from the list. So we'll do the same kind of list again, list iteration. I really like working with linked lists and trees. I think it's slick to be able to just iterate like that. I don't know, something about it I like. While current dot next equals, which means I should have a double equal here. Okay, I always forget about that. I'm used to my font choice, which the ligatures. I'm a big fan of ligatures. All right, current.next is not equal to null if current.next.value is equal to x, then we can snip it out of there. So we'll just take the whole node dot out, the whole node out. Current.next equals current.next.next. Okay, and in this case, we should always find a value. We don't need any sort of, we don't need to kind of do the weird case where we hit the end, because we can rely on this always being there because we're maintaining this list. So we'll always have a min. Okay. And so here, oh geez, I've got my return right here. That's funny. We definitely need to return the value for the function still. And up here I missed my actual iteration. Oops, current equals current.next. Okay, I think this solves the problem with the little creative reading. And we'll see how we did in the results. Error. Next equals. I did an equal sign instead of a colon. Come on, wish me luck. Oh, by the way, let's see, thanks. Do. All right, yeah, thanks for that solution. Runtime error. What is my error? X is not defined. It's because I named it result. A typo line 26 and need a void. Yep. Wait, line 26 typo? Oh, right. Yeah, sorry. Yeah, there's a big lag. The typo is there. The problem is there because in this case it's result. Sorry about that. I need to I should be able to get the latency way down on this side. Just I haven't messed with it. I'm using Streamlab OBS, which is nice, but for the streaming, but it doesn't give you all the options. So really, I just need to go to like the big parent OBS, the real deal. Okay, my answer was still wrong. Pop should return void. Oh geez, you're right. What the heck? Wait, pop should return void. Oh yeah, what the heck? Why would it return? That's weird. I've only ever seen pop return the value. What the heck? But I mean, that is what it says. I wonder if that's a typo. Okay, that looks good. -3, and we still got the problem with the min here. So I think it's time for our old friend, console.log. So the problem is either when we push or when we pop. So what I'll do here is basically just console.log. We'll just do the whole. I can't just log a linked list simply. So what I'll do is just make a little helper method called print mins or something. Dot print. And I don't need an argument. It's same trick here. Current equals this dot mins while current dot next is not equal to null. It's current dot next, and we will console dot log. And before this, we'll console dot log something like min list. And then we will print out the value. Okay, this is all I'm gonna do on separate lines, which I don't like. So I'm just gonna do a quick output array. All right. Current dot value. And then I believe I could just do that and output. And done. So now I should just be able to say like this dot print mins and be done. So whenever we push and whenever we pop, I guess I don't need to return null. I could just not return anything. That's null and void are not equal. Do. I'm so tempted to sign up to get this running faster. The pro plan gives you better performance. Okay, so still the wrong answer is what we expected. And having null as the head item is fine. It does mean my top may be incorrect. Because we've kind of got this root node just because it makes it easier for us to not worry about some certain edge cases. Yeah, so check this out. So, I mean, the min list looks good to me. So I think it's just literally the top here that might be wrong. No, that looks good to me. So I was worried that maybe I wasn't looking at the next. So the get min function. Return this dot, it shouldn't be heads, it should be mins. Dot next dot value. Yeah. Was that the problem the whole time? Wow. So that's funny. So yeah, just a stupid typo. That's what I get for copy pasting. All right. Let's go ahead and run this. I think it's a good solution. Thank you, Abdu. Output limit exceeded. Let me not print the mins. I think I'll save that to my clipboard just in case we need to do some more debugging. I hope not. Oh, I wonder if that counts as a failure. My poor ratio. Yeah, that was it. So, oh my gosh. Oh my gosh, this is the worst runtime I have ever done by far. So I'm slower than 94% of solutions. What the heck? Oh, my memory usage is also not good. What the heck, man? Oh my gosh. Okay. Well, let's take a look at some better answers here. So when they push, current min, well, that's interesting. They get the current min, and then on their stack, they push the minimum. what the heck of the value? Oh, wow. Okay, so I think I'm starting to understand. Because push and pop don't return values, we don't really even need to maintain a true stack, do we? No, I don't know. This stack dot pop. Look, their pop returns a number. Anyway, or blank dot val. Okay, yeah, that's fine. So maybe it was just my linked list. Maybe I should have just stuck with using the like array literal. I don't really see a big difference here in what we're doing. Nothing earth shattering. Now if we go over here, I suspect we might start seeing heaps. I mean, that's just kind of handling the case where it's an empty list, which we did by kind of just a linked list, that the structure that we used, and dealing with the current.next kind of avoided that. That's just a basic push pop. They're using array, it looks like. I mean, yeah, they're just using arrays. So when it came time to pop, that's interesting. They only pop the minimum array if the same element. So I don't understand that. It looks like they're using some sort of optimization I don't understand, where they only pop the minimum list if the minimum one happens to be on the top. So it's like they're cutting down on those minimum pops. So I don't understand that. Does anyone understand what the heck the secret is here? As far as I can tell, the only difference between their solution and my solution is I used a linked list, which should have had faster inserts. But it did mean more iterations. So I knew on my push and my pop that I was doing more work to iterate. Yeah, and even this, I don't know. I don't buy that this is a solution. So this is even closer to what you said, Abdu. This is like this is the more pure Abdu solution here, where they only push if it's minimum. But I don't understand that because I don't know. I don't understand how that works because they're not always pushing every number to the min stack. They only push the mins. And so when they pop, they only pop the minimum if it matters. Yeah, only the same number if it is the min one. Yeah, that's how I'm reading it too. It kind of boggles my mind as to how that works. Getting them in makes sense. But they only pop it if it's the minimum element. That means they kind of leave these zombie elements in there. I just don't understand how leaving those elements in there can result in a right answer. It seems like you could come up with a use case that could end up returning a zombie record when it shouldn't. So if the minimum length is 0, or this is a new minimum, that's the only time we push. Okay, well, I don't understand why this solution works. I feel like I could have come up with a use case where it doesn't. Yeah, right. So I am worried about popping the minimum. It existed before. Or even like if you get duplicate numbers. Okay, I kind of just want to take this and see. I can't let this go just yet. All right, so there's my beautiful solution. Oh no, I can't do that. All right. Well, let me just save this out to another file. Okay. So if we run this code, well, excuse me. All right, hopefully I muted in time. If we run this code, we should get the right answer. Okay, cool. But now we can do a custom use case. And let's see if we could find a way to break this. It's such a weird input format. I guess these are the operations. Okay. And what I'm saying is when we say get min, always returns this dot min and this dot min dot link dot one equals this dot min dot link dot one. Okay, so if I just push the same number, hey, I don't understand the order of the test case. Like, where do I actually push? Okay, so min stack returns nothing. Okay, I see. So in my case, what I want to do is I want to push. We'll do it 3 times, push. And we'll pop. No. We'll pop. Then get min. All right, and then here we're going to push. I guess it takes an array, which is kind of weird. So we're going to push the same number 3 times. So it should be the new minimum. And we're going to pop, which should return nothing. And the minimum should still be 1. All right, let's see how this goes. Maybe I didn't hit the button. Try that again. There we go. The first input name is not the constructor name. Okay. Okay. So I think that was just, how do they denote that? Was it just min stack? Which returns nothing. Oh, the get min I should have passed nothing, but I guess it doesn't matter. So, I mean, I guess I'm wrong. They got the right answer. That is what I expected. The get min doesn't take an argument, so that didn't matter. So how is it? I'm just going to run through their code here. So we pushed a 1, which pushed it on the stack. The minimum length was 0. Okay, so the min, so I'm just going to write this. Min stack the first element. So min became 1. We pushed another 1. And so we'll do stack is 1. They pushed another 1. Okay, so they pushed another one. That's fine. And they push it on the end. That's fine. And then if this.min.length is 0, nope. Or this.min at, oh, they did greater than or equal to. I missed that equal to. So they do push it on there. Okay. Foiled by a greater than or equal to. Okay, so that clears up one point of confusion I had about this. So they do push multiple copies of the bins, but they do not push a greater value. So if I change my input and did push 1, 4, that would make the stack 1 and 4. And in that case, we would never push that 4. And then if I did, so say push 1, push 4, pop. Oh, geez. So pop will get rid of the 4. Okay, let's try another example. I'm clearly reaching here. The solution obviously works, but I need to see this. I'm sorry. So we're going to push 4, and we're going to push 1, and then we're going to pop, which will get rid of the 1, and leave us with the 4. And now if I say get min, let's see what happens. So let's clear our stack. So we push 4. Okay. Oh, dang. That's right. 4 is the new minimum. We push 1. 1 is the new minimum. Okay. Dang it. You're right. I mean, I cannot disprove this, so it works. I'm having a hard time really internalizing that. So I'm going to drop my solution back in here because that's ultimately what I ended up coding. This one does kind of offend me a little bit. That's okay. So Abdu, you totally called it. So I was doing more work than necessary. Geez, excuse me. And yeah, that's how it is. So that's why my answers are not correct. So I did a linked list, which was kind of unnecessary. And I just did too much work. And this is where we ended up. But we did it. Well, we worked through how it worked. I feel like, I understand. I feel like the hint. Yeah, and Abdu, you totally called it. So, excellent work. All right, well, I'm going to sign off for a bit, and then later I think I'm going to be back on YouTube to try and do some unit testing of the Apache Beam project I've been working on. So watch out for that if you're interested, and hope you all have a great Friday. All right.